Okay, today is November 23rd, 2011. We're on lesson 5.3. We have a new formula we have on here today, Sine Law. Okay, this law helps us solve for triangles that are not right-angle triangles. So what was important is the three ratios we had before are used when we have a right-angle triangle. Because this is not right angle, we cannot use those three ratios to solve this. We're learning sine law today. Sine law is set up so that our angles and sides have specific parts of the triangle. This is very important. We're going to name this triangle. It doesn't matter which angle we call A, B, or C. It will matter what side we correspond to that. So what side we call A, B, and C after we've put in the angles A, B, and C. And what I mean by that is if I decide to call that A, B, and C, the sides have to be opposite of those angles. So because this was our angle A, side X will be side A. It's opposite of that angle. With angle B, the opposite side is our 9.2, so that will be our side B. And our angle C, our opposite side is right here, which we have no measurements for. Okay? Now, in our formula, the uppercase letters represent angles. So this is angle A, angle B, angle C. The lowercase letters represent the sides. In order to use this formula, we're going to plug numbers in and we need to set up a pair of ratios. Right now, I technically have three ratios altogether. But in order to solve, I only need a pairing. Who knows what pairing it'll be? Maybe it'll be C and A altogether, for all we know. We're going to plug the numbers in and see what we get to start. So, we have sine. Angle A is 55 degrees. So we have sine 55 divided by side A is our X. Angle B is 70. So we have sine 70 divided by side B is 9.2. And sine C, we actually don't know what that angle is. Is there a quick way I can figure it out?
Yeah.
How would I figure this out?
Add them all up and subtract it by 180.
That's right. If we add the angles together and subtract by 180, so we need 180 subtracted by 55 and 70. Is it 45? Our angle C is 45 degrees. Yeah, I think it is. Whoops. Hold on, ready? It is 55. 9.2. Oh, why did I miss that? Okay, so our other angle, is 55. So we're able to figure that out because we know a triangle adds up to 180 degrees. So we have sine 55, and we don't actually know what the other side is, so we'll just call it side C. Now that I've plugged in all the numbers, we have to pick out the important information. One of these ratios is going to be irrelevant to solving this. So, because we're looking for side X, no, we already have an X. Our X is here, so we're going to call it C.
Too crazy.
We're looking for sine 55 over X, so this fraction or ratio is very important. Now we have to pair it up with a ratio that has all of the information in it. So, if we look at C, we have sine 55 and C. I don't have all the information. I'm missing the side. But with our B side, we have the angle and we have the side. So, I can drop this part of the ratio. It's irrelevant for us solving it. It won't help us out. So our new ratio is going to set up like this. Sine 55 over X is equal to sine 70 divided by 9.2. Now, in order to solve this, I have to isolate x. So right now I have two fractions that are equal to each other. If you guys remember way back when in elementary school, I can simplify this by cross multiplying. Okay? If I cross multiply, I'll be left with 9.2 times sine 55 is equal to x times sine 70. And now before I equate anything else, I'm trying to isolate this x on this side. So how can I get rid of this sine 70 on the right? I'll divide both sides by sine 70. Okay? So when I divide the right side by sine 70, these two cancel out. And our final step before we actually evaluate everything is we have x. So side x is equal to 9.2 times sine 55 divided by sine 70. Now in the calculator, they're going to try to plug this in. Sine 55 times 9.2. So we get 7.5361, and you can keep going. The more numbers we write, the more accurate we'll be. We need to divide that number by sine 70. Okay, so once we figured it out, we discovered that x is equal to 8.01. We're going to say approximately 8 centimeters. So the other side of this triangle, our x was 8.0 centimeters long. Okay? Okay, example number 2. Example number 2, we have a triangle. They're asking us to determine all the interior angles. So, A, determine the interior angles. So in other words, we need to find all the angles of this triangle. Right now, I actually know none of them inside. But I have a bit of knowledge here. I do know that this straight line is equal to what? 180 degrees. And I do know that this part from here to here on the outside is 124. So in order to find the interior angle, what do I need to do? Take 180 and subtract 124. Yeah, it's right. 56 degrees. So our one interior angle we do have now is 56 degrees. That's this angle in here. Now that we have that angle, I can use my sine law to start to find other angles in this triangle. Now, I do have different letters for this triangle. It's called PQR. If you are knowledgeable enough to replace this with P and P, Q and Q, or R and R, that works fine. Or I can just rename the triangle ABC. Okay? So I'm going to write on the outside, I'm going to call this my angle A, in fact, and this will be my side A. Angle B, side B, and angle C, and side C. You can name whatever angle A, B, or C. Just make sure the opposite side is considered the lowercase version of that letter. So, let's start setting up our sine formula now, our sine law. Sine A, which is angle 56, so we have sine 56, divided by side A is 98, is equal to sine B, we actually don't know what the angle is, divided by side B, which is 112, and finally sine C, which we don't know, divided by side C. Now we could quickly take a look. Which of these ratios has no information? Sine C just happened again to have no information. So it's not going to help us in our calculations. We're going to drop it. We're just going to work with sine 56 and sine B. Now, like we said before, we could cross multiply to simplify, But in fact, I'm trying to actually get sine b by itself. So instead of cross multiplying, I'm just going to move over the 112. And because it's divided by over here, it's going to become multiplied by on this side. So we're going to get 112 multiplied by sine 56 divided by 98 is equal to sine b. So we have everything on the left side. I'm going to equate what we had. We have 56 sine divided by 98 times 112 gives us 0.94747 and continues. Now I'm going to keep that number in my calculator because I'm actually only looking for b, which means I need to move sine to the other side of the equation. Now we did this with our ratios before. If I got to move sine to the other side of the equation, it becomes the inverse. So we're going to get sine inverse of 0.94747 is equal to b. So in my calculator now, because I already have that number in there, I just hit shift and I hit inverse sine and it solves it for me. B is equal to 71.3. So we can round that to 71. Our angle B, or Q as they named it, was 71 degrees. Now I could use sine law again to finally find angle C, but there's a much faster way. I subtract both by 180 because a triangle's angles add up to 180. So we have 180 subtract 71. Yeah, I'm going to put it all up in a second. Subtract 56 equals 53. So we now have the measurements of all the interior angles here. 53 was our angle for C. Example 3 says that a wall is 1.4 meters long. So we're going to have our wall. And it says that the wall now leans to make an angle of 80 degrees with the ground. So if this is our ground, we have a leaning wall. And the wall is making an angle of 80 degrees from the ground. It's slanted. The building's tipping over. It says that a 2-meter board is jammed between the top of the wall and the ground to prop it up. Okay, so they're trying to keep the wall from falling over. This is our piece of wood that is jammed there. The piece of wood is 2 meters long. And we have the measurement of the wall, which is 1.4 meters long. The question says, what angle to the nearest degree does the board make with the ground? So we're talking about this angle here. We're going to call that our angle X. So we have our triangle. It's not a right angle triangle, which means we're going to have to use our sine law in order to solve this. Now, we're going to name this triangle. We'll have this as our A. We'll call this B and C. Now remember, the sides and the angle have to be opposite in order to have the same name. So we're going to plug it into our sine law formula. Sine A, we actually don't know what that angle is, so we're just going to keep calling it sine A. And side A, we don't know what that measurement is. Sine B is our X, and side B is 1.4 meters. And finally, sine C, which is our 80-degree angle, and our side C is 2 meters long. So we now have our measurements. So of our ratios, right now our sine A ratio, we have actually none of the measurements for this. So we're going to drop it off from the equation. How are you guys? Shut up. So we have sine x divided by 1.4 is equal to sine 80 divided by 2. Now we need to solve for sine x, which means all I have to do is actually move 1.4 to the other side of the equation. When we go to move 1.4 to the other side of the equation, because it's divided by, we're going to have to multiply when it's on the right side of the equation. So we have sine 80 divided by 2 multiplied by 1.4. Okay? So we're going to equate that before we move sine to the other side of the equation. So when we equate that side, what do we get, Chris? All right, well, let's do the side first. So we have sine 80 divided by 2 times 1.4. 0.689, and it goes on forever. We're going to keep that number in our calculator so that when we move sine over, it becomes the inverse to that number. Yep. So all I have to do is hit shift, inverse sine, we have 43. Now it says to round it to the nearest degree, so we're going to round this to 44 degrees. So our angle x is now 44 degrees. So we've figured out part A. Now, part B is a trick. They want us to actually find out how far away this board is from the wall. But in order to do that, I won't be able to set up my sine law again. I want you guys to notice. So, we now have a new measurement. So I'm going to redraw this part. Whoops. We plugged in our answer. We got 44 degrees. So we were able to plug in for angle B, 44. The problem is I still don't have any of the measurements for sine A. We still have to figure out side A, but I actually don't have the angle. What is a quick way of finding this angle?
180 minus 2 by.
That's right. So in order to find this side, we need to take 180 and subtract the other two sides. So our angle A is 56 degrees. Now that we have that, we have 56 degrees, I can actually pair this up with either of these. I can decide to pair it with this ratio, or I can pair it with the other ratio because both of those ratios are complete. Either one is still going to give us the exact same answer. So what we'll do is we'll do both on the other page just to prove it. So we're trying to find sine A, and both of our other ratios are complete. I'm going to set it up equal to either of the other ratios to show that we'll get the same answer. So in one aspect, we have sine 56 divided by A equals sine 44 divided by 1.4. In our other example, we have sine 56 divided by A is equal to sine 80 divided by 2. Both will get us the right answer. I'm going to move through this quickly. We would cross multiply, so I get 1.4 times sine 56 equals A times sine 44. And on this we'd get 2. 56 equals A sine 80. When we bring the sine 44 over, good. When we equate both of those, we'll end up with the same answer. And I'm going to do it quickly on the calculator here.
1.67 and 1.67.
A equals 1.67.